Where the flux are we? So there's a direct answer to this. We're here in Fiddlers, so we can cheer to that. But another direct answer to where the flux are we? Where are we? Well, as far as we know, we are about 25,000, a little bit more than 25,000 light years from the center of our galaxy. So from the time that the dinosaurs were around, we were at the other side of the galaxy. We had already gone around the Milky Way. So that's where we are. I really just want to share some thoughts from a lot of observations that I've done in the process of observing, and things that I really love about observing, and some insights that I wanted to share with you. So rather than it being a style of a talk, like presentation, I really just want you to think you're at a pub, and I'm just sitting down next to you. You know, we just happen to say, you know, where are we? It's one of those simple questions. So just to explain what I mean by flux, as astronomers, we're always talking about flux. If we're radio astronomers, we're talking about Janskis. And to visualize flux, you can see this flow throughout the Amazon rainforest, above in the clouds. It's really amazing. And flux is really the density of flow, the power per surface area. So if there's any takeaway, you know, that's what flux really is. So you can measure it in watts per square meter. And as I said, radio astronomers talk about Janskis, which is 10 to the minus 26 on that order of watts per square meter. So talking about flow, we're embedded within this flow, the Hubble flow. At this point in the universe is expanding, and it's accelerating in its expansion. And to get to this point, there was a huge distribution of matter that through gravity, everything sort of came together. And there's always this flow that we can think about. And when you think of astronomers, you can think of two categories. You can think of astronomers who are more theoreticians, who play God, and they use supercomputers, and they, you know, extrapolate from initial conditions based on the laws of physics to where we are. There are also observational astronomers who deal with observational data. And then there's a small sliver of observational astronomers that I find myself fortunate enough to say that I'm a part of, who live the romantic life of actually going and getting the data hands-on. And in that process, you can think of it as just part of the job. But for me, I really try to be more philosophical about it. And so one of the things that I really appreciate about observing is that if I'm pointing the telescope to a point in the sky that somebody maybe has never looked at before, I can think about where we are at this moment in terms of this overall flow that we're just a part of, which is really quite incredible. So just that concept itself, that we're always a part of something that's ever expanding. So here are a couple telescopes that I've had the opportunity to work at. A couple weeks ago, I was in Granada at the 30-meter telescope, and it's a couple thousand meters up. And you might have heard from the previous talk where there's the astronaut testing, and they have to go through all these high-altitude conditions and everything. I can definitely say there's less oxygen when you get higher up, and things definitely age faster. In fact, you can take a cesium atom, which is a really precise clock, and you can time two cesium atom clocks together, take one up a couple thousand meters, and when it comes back down, it's going to be a nanosecond faster. So maybe that's why I've grown so much hair, because a couple weeks ago, I was bald, and I just got back from Granada. I was up there for just 2 weeks. So we know where we are by observing. And that's a really profound thing in terms of where we've come in terms of humanity. So we have gone far beyond just locating reference frames and landmarks and saying, oh yeah, that's over there. We're right here. You know, maybe if we travel there for a couple days, and we still see that's going to still be there. We can sort of figure out where we are. So the whole process of observing, I think we've often taken for granted the real miracle and just really understanding where we are and going far beyond just looking at landmarks on the Earth. one thing that I like to think about when I'm observing is that there's always a physical scale to be considered. You can see how California and the U.S. and Italy are roughly half of Pluto. They could stretch over the diameter of Pluto. That gives you an impression of some scale. The distances between things are just really profound. Like I said, it's 25,000 light years. It takes light a whole year at a foot per nanosecond, which is a third of a meter per nanosecond. So 25,000 light years just to get to the center of our galaxy from where we are. You can think of neutrinos, 10 to the minus 24 meters. There's 100 trillion neutrinos that pass through our bodies every second, just from what's output from the sun. These are lightly interacting particles that just go right through us every second, 100 trillion. These things often just go unnoticed. And then you can pick someone's hair next to you and just take a look, and that's about the smallest you can see. Maybe you have some trouble over there. The interesting thing also is that as astronomers, we're always looking back in time. I always find that fascinating. And it gives us an impression of time itself, but because of special relativity, general relativity, we understand that time is really not as fixed as we think it is. As I mentioned, when you take a clock up to a few thousand meters and bring it back down, it's actually faster because it had less of a gravitational pull from the center of the Earth. We define time from the start of the Big Bang. What was before that, I can't comment. Nobody can really comment. We can't really see even 300,000 years after the Big Bang. But the thing is that space-time exists in a four-dimensional realm. So for all we know, the future could be to our left or to our right. And our future always exists because of this four-dimensional space-time. And so the real important thing is that it's the intervals between things, the cause and effect, that really change what's happening and allow us to measure what's happening. And when we look back in time, we look at things with respect to where they were prior at a different event in space-time. So it's just something to think about. It's rather abstract. I don't think many astronomers actually think about the fact that we're embedded within this space-time all the time. We're just crunching numbers on our computers. So just to try to bring home the concept of what it's like to actually observe, for me, I have a lot of experience observing more at radio frequencies. But on the far left, you see in this particular image, ultraviolet frequencies, visible frequencies where our eyes see, and you see whether or not you can see through the atmosphere at those frequencies. So at some frequencies, it's just a complete wall. You can't see anything. But as you go to specific pockets in our atmosphere, from the ground, you can see through the atmosphere into the Milky Way or into the extragalactic space. And as was mentioned, Sophia, because it's so high, it allows you to see above some of these walls in the atmosphere. If you go to very low frequencies, you get to the radio frequencies, which are interesting because there's just a clear window into the whole universe, basically. If you go to very, very low frequencies, hundreds of megahertz, that's where our TV stations have communication channels. Our cell phones are detecting 1 to 3 gigahertz, roughly. So a hertz, of course, is a cycle per second. So and measured in terms of the electromagnetic radiation, that's what we're measuring. So if it's a gigahertz, that's the particular frequency. It's just like a radio station has a specific frequency. So you can see in the US, there's an allocation for radio frequencies. And a small sliver of that is for radio astronomy. The rest is for naval communications and GPS satellite communications and everything like that, because the atmosphere is so clear to radio waves, radio light waves. If you go to very, very low frequencies, you can get to hundreds of hertz, which is on the order of where instruments have their range in what they output. So you can go from the bassoon to the vocal soprano, the alto sax, the alto vocal. These are hundreds of times per second. But the difference here, of course, in the analogy, is that these are not sound waves. These are not light waves. These are sound waves. So they are slightly different. The wavelength is, you can measure it as the same, but how you determine the wave, sound is through the compression, and light is an electric field and a magnetic field. So my final thought that I would like to share with you today is a connection that I thought of recently as I was observing. I was done observing. I went to Amsterdam, and there was a recording studio that I am doing some work at, and it just dawned on me how many similarities there are. And the fact is that when I'm observing, now I don't know whether or not I'm recording music or I'm observing and recording data from some extragalactic signal. Because let me just try to paint a picture. So at the control room, at a radio telescope, you're at a control room. You're the observer. You're going to point the telescope. What you need to do is you need to tell the telescope operator that, I want to use this instrument for the telescope, and I want this instrument to be at this specific frequency of light so that I can measure whatever I want to measure and do the science. And the telescope operator goes and changes the hardware. And in the same way, when you go to a recording studio, you're getting there. There's the person that goes and sets up the microphones. Marcel is this person right now, the sound engineer. You have the person who does all the hardware setup, the one who gets everything situated, makes sure that the musicians are in place, and then you proceed. And when you're recording data from the telescope, the light bounces off the dish, hits the focal point, gets received by the detectors, and then from there, a fiber optic cable usually passes that information to the computer. And because we live in a digital age, that's sampled at certain chunks. So we take in information at so many chunks. And it's the same process when you're recording music. You have a microphone, you have a recording software, and you're sampling the music in certain chunks. When you are recording, sometimes you have to take multiple takes. You're not always going to lay down that certain lick or play a certain way each time. So you want to take multiple takes, have a lot to work with. You can cut pieces. And a similar approach is actually taken in astronomy, because I'm trying to, for instance, observe a signal that has the power of a snowflake hitting the ground. And in order to really get that signal to come across above the whole atmosphere, I need to look at that point in the sky for a very long time, take multiple takes of integrating on that target to receive more and more light. In the final stages, after the musicians have recorded their album, let's say, there's a process of mixing. And so you have to change the levels. You can raise the volume or raise the bass in one instrument, raise the treble in some other instrument, and you mix it all together. And in the same way, when you're processing radio data, often you're just adding up all of the different times that you took information, and you're averaging it together, and you're making it look equal to some extent. I can go into more details. I'd rather not. So that's my final slide, actually. And I really just wanted to leave you with this impression of, just thinking about simple questions like, where are we, in a different manner. So what are we? Who are we? And so on. And so one of the ways that I like to observe daily life is to play the drum. And so I'll just play the drum for a couple minutes. Sometimes I play the drum while I'm observing, because you can set the telescope to point at a certain point of the sky, and then it goes for an hour. So you got to do something, right? So sometimes I'll drum. So I without further ado, I just want to play for a couple minutes, and then afterwards, Eduardo will share with us some news about the black hole discovery. So thank you very much for your attention.